Okay. Hello, everyone. And this is another session, Module 2, CCNA 3, Single Area OSPF version 2 configuration. So in this module, we'll be looking at the configuration part after the first module, which we looked at the concepts of single area OSPF. And getting straight into it, the objective of the module is basically to implement single area OSPF in both point-to-point and broadcast multi-access networks. Which of the two networks we discussed in module 1, point-to-point and multi-access? Module objectives, we have configurations of the router ID, configurations of single area OSPF in point-to-point, obviously in multi-access networks, configurations of the priority to influence designated routers or backup designated routers in a multi-access network. We also look at implementing modifications to change the operation of single area OSPF, modifications in cost, etc. We'll configure the OSPF default route, and lastly, we'll look at how we can verify the OSPF implementations. This is a very quick summary before we get into the actual configurations, starting with the OSPF router ID. Right. How do I remove this? Right. So here we have the reference topology that we're going to be using. Is in theory, we are going to talk about how you configure an OSPF network. So this is the reference topology we are going to be using. So as you can see, I think this is a point-to-point. This is a point-to-point network, not a multi-access network. That's one thing we should note first. We have a couple of loopback interfaces that are configured there. We have access to the internet, right? Another loopback interface. There are a few things to note there. And this is a single area, which means this is the backbone of our network. We should configure it as area 0. This reference topology is basically what we're going to be using to explain the configurations for our OSPF in the single area. Right. Router configuration mode. So the first configuration in OSPF is basically enabling OSPF. That is the first thing that you need to do, enabling OSPF. And we do that by using the process ID, by configuring the process ID. So the OSPF is enabled using the router OSPF process ID global configuration mode. In the global configuration mode, here we have the router OSPF. In this case, the process ID being used is number 10. What is a process ID? This is just a number, as you can see, a number between 1 and 65,535, which is used to identify a particular routing instance. It is used to identify a routing instance. Routing instance. Instance. Right. The process ID is an identifier of a routing instance. We can have many routing instances in a single area, but we will see as we do our configurations, at this level, we'll just be talking of probably one process ID in a single area. In this case, we'll be using router OSPF, the ID being number 10. This is just a number, right? From that command, you see we then enter the router configuration mode. If you input the router OSPF command, you will enter the router configuration mode. And from that mode, you can see we can be able to configure the area, the costs, the distance. We'll also configure the default information. I think in this module, we'll discuss and configure the passive interface as well as the router ID. So all those configurations are then done from the router configuration mode. So in summary, number one, the first thing we do when we want to configure OSPF in a single area, we configure the process ID. That is our first starting point. From there, we go to the router IDs. A router ID is just an identifier, a unique identifier of a router in an OSPF network. So every router in an OSPF network needs to be identified. As much as every device in an IP network needs to be identified by an IP address, every router in an OSPF network needs to be identified, and it is identified by a router ID. So you see the router ID, it has the same representation as the IPv4 with 32 bits, with it being a 32-bit value. It is the same as an IPv4 address, right? You see, we'll be using that router ID in two instances. One, in the participation and synchronization of OSPF databases. So if you can recall, in module one, we talked of states in OSPF, starting with the init state, which is the initial state. Then when we go to the exchange state, just before the exchange state, we had the exchange start. And in that state, we discussed, this is where two routers discuss who has the highest router ID, and the one with the highest router ID will begin the setting of the database descriptions. So our router IDs are very important in the sense they are used in that start state, right? Number two, they are used in the participation in the election of the designated router. So in a multi-access network, there is need for a DR and a BDR. And how are they chosen? They use the router ID. The one with the highest router ID is chosen as the designated router, the second highest being the backup designated router. So the router ID, very important. It's very important in an OSPF network because of these two things: participation in synchronization of databases and participation in the election of the designated router. Router ID order of precedence. We briefly touched on this as well in the previous module. Order of precedence. One, the router ID can be manually configured using the router ID command, obviously in the router OSPF configuration mode. So number one, it can be manually configured, explicitly configured using that router ID command. That's number one. What happens if not manually configured? Two, if there is a loopback interface that is configured, the highest address of any loopback address configured on the router automatically becomes the router ID. So let's say you did not configure your router ID manually, then if there is a loopback interface, the loopback interface you will be used instead. If no loopback interface is on your router, then the highest IP address of any physical interface on that router will be used as the router ID. So these are just three ways in order of precedence how a router ID is chosen on a router. It is, however, recommended, it's best we use option number one, which is to manually configure the router ID. Configuring a loopback interface as a router ID. This is just a way of configuring an interface, right? A loopback interface, I will have to say this. A loopback interface is a very reliable interface. In this case, how? So let's say I have a router. This is my router. I have two physical interfaces. So this is physical. This is physical. So these are my Giga Ethernet. Let's say this is Giga Ethernet 01. This is Giga Ethernet 00. Then I have a loopback interface here configured. The reason why, in order of precedence, the loopback interface is more preferred than a physical interface. A loopback interface is a virtual interface. So that is a virtual interface that we configure on the router, which is always up, unless the administrator changes it to administratively down. So that one is always up. What that means is a very reliable number, or let's say ID, to use as a router ID. It's very reliable because it's always up, it's always there. Unlike these physical interfaces, if this link is down, a physical interface can be up, can be down at times. So if the link is down, even if the administrator doesn't administratively turn it down, the link can be down depending on what is on this other end. So if this link is down, therefore the router ID has to change. Therefore, the elections or the participation in DBDs, it has to change. The election in the DR, it has to change as well. So the loopback interface is more preferable because it is a virtual interface. It is always active, therefore providing a dependable source for the router ID. Right. How do we then configure the loopback interface? This is how we configure the loopback interface. We enter the interface configuration mode, interface loopback 1. It can be loopback 0. It can be any number. You enter the IP address, and if you take note of the IP address, it has a 255.255.255 mask, 32-bit subnet mask. Why? The reason why is because we configure a loopback interface as a host route. Why? Because a host route is not advertised. It does not appear in the routing table. Since it is just a virtual interface that we created, this is not a real network we are using. So why will it appear in our topology, in our routing table? It does not need to appear in our routing table because it's just a virtual interface we created. There is nothing there. Therefore, not to allow it to appear in the routing table, it begins with giving it a 32-bit subnet mask, 255.255.255.255. That makes it not appear in the routing table. Things to take note of. Okay, right. Explicitly configuring a router ID. Right, as we mentioned, this is the first thing to do. You should explicitly, manually configure the router ID. Very simple. We use the router ID command in the router configuration mode. So let's say router 1, 2, and 3, they have these three router IDs respectively. You just configure them as they are. There is no subnet mask. It's just a number like this one. 1.1.1.1.1. A router ID uniquely identifies a router in an OSPF network. So these are the identifiers of these three routers respectively. And this is how you configure them. Modifying a router ID, right? So let's say you want to change your router ID. It's very simple. With one thing to note. How do you change it? You just use the same command, router ID. In this example, we can see if we show the IP protocols, we can see the router ID is 10.10.1.1. And we want to change that to 1.1.1 in this line. So we just enter in the router configuration mode, router ID 1.1.1.1. We have changed. But for that change to take effect, there is need to reload the router, number one. the router needs to be reloaded, or the OSPF process needs to be reset. But you see, it's much easier to reset the process than reload the router. Because if you reload the router, then probably you did not save any changes. All the changes that you've made will be erased from the router. So it's much preferred to use the reset process. And how do you reset? From this line, this is the command we use to reset: clear IP OSPF process. After you reset, here we're showing the protocols again. You can see the router ID has changed from 10.10.11 to 1.1.1.1. So I think the important thing to note here is the clearing process. Sometimes you change, but if you do not clear, then the change will not take effect. Even if you go and show IP protocols, before you clear the process, the router ID will still remain as 10.10.1.1, even if after you've changed it. Right. Point-to-point OSPF networks. We discussed this, the definitions, what the point-to-point network is. Now, how are the networks advertised in a point-to-point network? How are they advertised? Let's have a simple network here. Let's use the same network we were given as the reference. Right, this was our reference network. Let's look at this. This was our reference network. Right, how are the networks advertised? Right, if you look at R1, how the networks are advertised, if you look at R1, it is directly connected to this network here. It is another one here, number 2, and this network number 3, directly connected to those networks. So in R1, you configure the networks using the network command in the router configuration command. In the router configuration mode, the network command, you enter the network address. You are trying to advertise the wildcard mask, the area, and the area ID. With the area referring to the OSPF area. In this case, we only have one area, and by recommendation, it should be area 0. All right. Going back here, the network command. So it means we're going to advertise this network right here, which is 10.1.1.12 /30. /30 is 255, 255, 255, 252. That is /30. Now, we use the wildcard mask to advertise a network. I'll explain in the next slide what the wildcard mask is. And for this case, the wildcard mask is 0003. So network, the command, the IP, the mask, the area, and 0. That means router 1 is now advertising this network right here. So a router advertises its directly connected networks because that's all it knows. Though anoziva chete my networks are directly connected. It doesn't know anything else. Right, so we have 3 networks here. This is number 1, the other one 10.1.1.4. This one, number 2. The mask is the same, and the area is the same. And the last one, we have this one, which is 10. Let me write it here. 10, 10, 1, 0, with the mask 24, meaning the wildcard mask becomes 1, 2, 3, 2, 5, 5. The area is 0 as well. So these are the 3 networks we are going to advertise, and this is exactly how they were advertised. Let me see. Okay. It's probably in the next slides. Let me see. All right. Voila, here. This is exactly how they were advertised here. All right. So I skipped a couple of slides here, which were explaining the wildcard mask. Let's go there. All right. Here in this slide, this just summarizes how do you advertise a network. To advertise a network, you use the network command, the network address, its wildcard mask, the area, and the area ID. Explanation of the wildcard mask. What is the wildcard mask? Right. The wildcard mask, it is typically the inverse of a subnet mask configured on that interface. We can use the wildcard mask sort of as a filter. Let me use the word filter. A wildcard mask is a filter of IP addresses. It identifies a specific range of addresses which we can match or which we can ignore. And when matched properly, then a packet is passed through or allowed to pass through. If it does not match, that packet is dropped. Right, the wildcard mask, how is it calculated? So let's say we have a /24. It means its mask is 255, 255, 255.0. That is the subnet mask of /24. To calculate the word mask, you subtract this value, the subnet mask, from a 32-bit mask, which is 255.255.255.255. And if you subtract /24 from that, what do we get? 255, 255, 255, 255. So these cancels out this cancels out this cancels out this, and we are left with the 255. And this becomes the wildcard mask. And how does it work? You can apply this for any given subnet mask. And how does it work? I'll use an example to explain how a subnet mask filters. All right. Let's say we have a network ID 192. Let's say we have a network ID 192.168.10.0, excuse me, /24. Right? It means its wildcard mask is 0000255 because it's a /24. What does it mean as well? When I talked of filtering depending on what is being matched and what is being ignored. When you have a 0, this is a match. When you have a 0 on the wildcard mask, this is a match. When you have a bit 1, this is a ignore. So you see, where all these in all these places we have a 0. It means we match 192, match 168, match 10. And here, these are all ones. It means we ignore any value that is in this area there, in these 8 last bits. Let me explain a little bit more. Let's say we have a packet which is destined for the network, for the address, destination IP address 192.168.10.10. Right. If a network is configured on the router as this 192.168.10.0 with the wildcard mask 0000255. With this specific address, it matches because there's a 0, there is a match. 168, there is a match. 10, there is a match. This 10 here is not the same as a 0 that is there, but since we have a 255, which means all ones, it means we can ignore whatever is in these last 8 bits. So we can ignore this. Therefore, any value here can match. Therefore, this IP address is not dropped because it matches in all, let's say in all the 4, 1, 2, 3, 4 places. It matches. Another example which does not match. Let's say we have an IP packet destined for 192.168.9.10. Right? Here it matches because there is a 0, it matches 192. Another 0, it matches 168. another 0, it needs to match with 10. And 9 is not the same as 10. Therefore, this packet is dropped because it does not match with the wildcard mask. That's how the wildcard mask. It is used to filter. It is used to filter a range of IP addresses. So you can see one thing to note here, if we have a 0, therefore it needs to exactly match whatever is in the given address. It needs to match what is here. If we have a 1, you ignore whatever is there, just ignore it. It means, for example, in this case, we have all 1s with a 255 here. That is all 1s. It means here we can have any value there. Dot 1, it ignores. Dot 2, dot 100, it ignores because it is a 255. Wildcard mask, hopefully understood. Configuring OSPF using the network command, we've already done this. This is how you advertise networks on a router. So R1, these are all the networks that are being advertised with the IP, the network ID, the network address, and the wildcard mask. With R2, is there an R2? Let me see. Let's try to see what will happen on R2. Here with R2, here, there we have R2. R2, we have this network connected. We have this network as well connected, number 2. And we have this network connected. And lastly, this one. So R2 will advertise 4 networks. So you just configure those networks. This one, it will have a wildcard mask with 255. This one with 0003. Where is the 3 coming from? If /30 is this address right here, 255, 255, 255, 252. If we subtract 255, 255, 255, 255, this cancels this, cancels this, cancels this. 255 minus 255 is equal to 3. That's where the 3 is coming from. For the same, this one, it also has a wildcard mask, 03. And this one, number 2, it also has 03 as well. And that is how networks are advertised using the network command. Right. As an alternative, OSPF can be enabled by specifying the exact interface. Specifying the exact interface. Right. So in the first example, we were specifying the network being advertised. The network. So we looked at the network and its wildcard mask. In this second example, we'll look at the specific interface, the IP address of the specific interface. Right. Going back to our reference, let's look what is the IP address of the specific interface. All right, let's look at R1. This interface here, the IP address is 10.10.1.1. This one is 10.1.1.14. 14 there, and this one is .5. And this interface here is 10.1.1.5. So these are the IP addresses of the interfaces which are directly connected to the networks that we want to advertise. So the first example we use to advertise, we use the network. So we use this number here. In the second example, we will use these numbers here. The trick now is after using the IP address of, excuse me, of the exact interface, it needs to be followed with a quad 0 wildcard mask. It needs to be followed by a quad 0 wildcard mask. 0 meaning match. When you have a quad 0, it means you need an exact match of the IP address. And that is the case with this one, an exact match. So the advantage of specifying the interface is the wildcard mask calculation is not necessary. It's no longer necessary to calculate the wildcard mask. So when you are using the network, it needs to be followed by a wildcard mask. When you are specifying the interface, that's number 2. When you specify the interface, it is followed by a quad 0. So you just specify the exact IP address of the interface, which is directly connected to the network you want to advertise, followed by the quad 0. That's another way, number 2, of advertising networks in OSPF. Right. Number 3, I think there's a third way. Right. Number 3, how do you advertise networks in OSPF? This is number 3. You configure directly on the interface using the IP OSPF interface configuration mode command. Right. So you go directly to the interface which is connected to the network which you want to advertise. Going back to our reference, right? The interfaces that we have. What are the interfaces that we have? Looking at router number 1 again. So the interfaces that we have this one, gig 0/0/0, gig 0/0/1, loopback interface 0. Those are the 3 interfaces that we have. So the third way makes use of those interfaces. You enter the interface configuration mode, interface gig 0/0/0. That is entering the interface configuration mode. Once you're in the interface configuration mode, you input the command IP OSPF, the process ID, and the area. So in this example right here, the configurations that are being made here, you can see we have no network. We are removing the networks that we had configured before using the network command. We remove them. Then we reconfigure those using the interface configuration mode. So we enter the interfaces. Let's see, the first interface was 0/0/0 and followed by the command. We entered 0/0/1 followed by the command. We entered the loopback 0 followed by the command. So in summary, we have 3 ways. Let me see, right. In summary, we have 3 ways that networks are advertised in OSPF. 1, we use the network itself. What is the network that we need to advertise? The network that we need to advertise is the directly connected network. We enter the network, we use its subnet mask to calculate the wildcard mask. We use the wildcard mask. Number 2, you enter the IP address of the interface. When you enter the IP address of the interface, you use the quad 0 wildcard mask. Number 3, you enter the interface itself. You enter the interface mode, config mode, and you configure OSPF directly on the interface. So these 2 commands, they are being configured in the router configuration mode. But this last one is being configured in the interface configuration mode. So either one of those 3 can be used to configure your networks. To configure networks that are being advertised. Sorry. All right. Moving on. The passive interface. By default, OSPF messages are forwarded out on all OSPF-enabled interfaces. However, these messages only need to be sent out interfaces that are connecting to other OSPF-enabled routers. Sending out unneeded messages affects the network in 3 ways: inefficient use of bandwidth, inefficient use of resources, increased security risk. Right, so let's say this is our network, right? Here we have a LAN. So we have our PCs in here, right? Here we also have a LAN, and we have our PCs here. This is our network, right? R1, R2, R3. When we talk of passive interfaces, we are talking of interfaces that are not connected to other routers. So if you look at this interface, this is an active interface because it is connected to this. This is active, this is active, this is active. But if you look at these two interfaces here, these are passive because they are not connected to other routers. So we talked of all the messages that are sent from the hello packets, from the link state advertisements, link state requests, link state updates. Those are all messages which are being exchanged between routers. But if this is not connected to a router, where are those messages being sent? If they are sent to this network and there is an intruder, then we have a problem. Problem number 3, increased security risk. If those messages are sent to a PC, an intruder can manipulate those messages that are being sent, right? That's a problem. In terms of inefficient use of bandwidth, there is no need to be sending messages to a local area network because devices here will process that. Even the router itself, it is processing all those messages which are not being used. So it means we are inefficiently using bandwidth. Problem number 1. And problem number 2, evidently inefficient use of resources because devices here will continue discarding all those messages because they don't know how to use those messages. So not to allow messages to go to those interfaces, we have a command which we use passive in the router configuration mode. We just enter the passive interface command and we enter what is the interface which needs to be passive. So here in this example, we can see the loopback0 interface needs to be passive. Why? Because I think that is the one which is being simulated to be our local area network. In this case, this loopback0 is a passive. This one is passive. You also realize this is passive as well as it goes to the internet. Why do you need to send routing messages to the internet? Anotorwa, and they'll be used to attack your network. So this will also be a passive. So a configuration is there that disables those messages from being sent to that interface. That's where we have the passive interface router configuration mode command. Right. OSPF point-to-point networks. Okay, I can see less than 1 minute. Let me just end it here so that I can continue in another video session.